All right, so you're building an AI machine in 2025. You've got a really interesting choice to make. We're going to break it down today, pitting a legendary champion against a brand new contender to figure out where you should put your money. So this is the big question, isn't it? Do you go with the proven workhorse, the RTX 3090, famous for its absolutely massive pool of memory? Or do you bet on the new hotness, the RTX 5070 Ti, which is a modern specialist built from the ground up for efficiency? Let's dig in. First up, let's talk about the veteran in the ring, the GeForce RTX 3090. You know, even a few years after it came out, this card holds a really special place in the AI world, and it's for one very, very big reason. And that reason is this number: 24 gigabytes of VRAM. This colossal memory buffer is pretty much the single biggest reason the 3090 is still so incredibly relevant for anyone doing serious AI work. It is the key to its staying power. So what does all that memory actually get you? Well, it means you can load up absolutely huge, complex models and use bigger batches of data when you're training. That can slash your iteration time. And it's not just the memory size, it's got the bandwidth to back it up. Hundreds of tensor cores for all that AI math and, really mature, stable software. It's kind of a brute force approach, but wow, is it still effective. Okay, now let's meet the challenger, the RTX 5070 Ti. And this card, it's not just a simple step up. It represents a totally new way of thinking, prioritizing a modern architecture and features built specifically for AI. And here's the key. Right from NVIDIA themselves, this thing is built on a Blackwell architecture. That's the same tech powering the world's most advanced AI data centers. So what they've done is they've taken that pro-level DNA and squeezed it into a card that you and I can actually use. Now, what's really cool here is the focus on being smart instead of just big. Its new tensor cores support efficient data formats like FP4 and FP8. You can think of it like zipping a file. It can shrink your AI model's footprint, letting you do way more with less memory. And then there's that L2 cache. It is massive. It's like a super fast onboard memory buffer that just keeps the GPU fed with data, which means faster results. And you get all of this while being more power efficient. Oh, and it's got the latest media engines if you're doing video stuff too. So we've got two totally different approaches here, right? We have the memory-heavy veteran versus the slick, architecturally advanced newcomer. Let's put them side by side and see how this all shakes out on paper. This table really tells the whole story. You can see the 3090's huge advantage in raw memory, 24 gigs versus 16. No contest there. But then, just look down the list. The 5070 Ti is on the newer Blackwell architecture. Its L2 cache is a wild 8 times larger. Its tensor cores are 2 generations newer, and, this is huge, they support FP4. And it does all this while sipping 50 fewer watts. It's the classic battle, raw power versus modern smarts. Of course, specs are just numbers on a page. Who really cares about that? The real question is, how do these differences actually play out when you're running the AI workloads that you care about? Let's get into some real-world scenarios. Okay, let's start with the big one, training. If your main goal is to train the absolute biggest, most complex deep learning models you can on a single card, which one do you pick? Yeah, for this job, the answer is pretty cut and dry. It's the RTX 3090. When you're training, VRAM is almost always your biggest bottleneck, and the 3090's 24 gigs just lets you fit more model and more data without hitting that wall. But hey, training is only half the battle. What about taking a model that's already trained and actually using it to get results? That's called inference, and that's where speed and efficiency are everything. And right here, the tables totally turn. For inference, the RTX 5070 Ti is, without a doubt, the better choice. Its whole architecture, that giant L2 cache, the support for efficient formats, it is literally designed to run modern AI models faster and cheaper. Now, for a fun one that I know a lot of you are into, making images with tools like Stable Diffusion. This is a really interesting use case because you can actually make a good argument for either card. So this one's a little more complicated. If you're pushing for super high resolutions or you're using some experimental tools that aren't very optimized yet, that raw memory on the 3090 can be a real lifesaver. But if you've got a modern, streamlined workflow, the 5070 Ti and its smarter architecture will probably generate your images faster. So, after all that, how in the world do you decide which card is right for you? Well, it really just comes down to figuring out what your main bottleneck is. This slide basically sums it all up. You go with the RTX 3090 if you are constantly running out of VRAM and your projects are crashing.
It is the king of capacity, plain and simple. But you choose the RTX 5070 Ti if your models can fit within its 16 gigs, and what you really care about is pure speed, efficiency, and having the latest tech.
So at the end of the day, it's a choice between raw capacity and modern efficiency. If you can figure out which one of those is holding you back the most, you'll know exactly which card to buy. Now, this has just been a high-level look. If you really want to get into the weeds with the detailed benchmarks, the performance charts, all that good stuff, you should absolutely read the full analysis that this was based on. You can find it over at https://www.bestgpusforai.com. And don't worry, we've dropped that link for you right in the description. So that leaves us with one final question for you to think about. What's more important for your work? Is it massive model capacity or is it next-gen efficiency? The answer to that question tells you everything you need to know. Thanks for watching.